Hello everybody, this is another Eletrocursos do-it-yourself video. In this time, I will show you an electronic Morse code manipulator for especially amateur radars. But of course, if you want to make this and practice and use this as training proposal, you can use it also. And it's a very small equipment, as you can see here. So in comparison with my hand, you can see I could reach a really small space to put all my electronics here inside. And this is very interesting. Here in this connector, you can put a stereo cable, okay, a stereo plug, and you can connect your transceiver here through this output of the equipment. Here it's the power supply input. So it's possible to feed from 9 to 15 volts. I tested this with 9 and 13.8 volts, which is the most common specification for transceivers, okay, as you probably know. And this equipment, you can see there are different features here, and there are different possible modes for operating here, okay. Again, sorry for my audio. I'm recording this part of the video with a camera and an internal microphone of this camera. So this is the reason why the audio is not so good for this moment of my video. Sorry. And of course, I will share at the end in my website all necessary files that you can use to produce your own equipment. Be careful. I will give you some hints about electromagnetic interference, about radio frequency return, but it's up to you to make your equipment. So it's in all your responsibility to produce this and use this in your equipment. So I did this, I tested in my transceiver, which is Yaesu FT950. It works really fine. But of course, it depends on the experience of the technical guy who will assemble this stuff. Okay, be careful. Inside of this equipment, I'm using a really small speaker, which can reach about half watt, which is more than enough to make a really loud sound that you can easily understand and listen in a room, for example. I put it here also a potentiometer, okay, that you can increase or decrease the volume of this application, of this equipment. So I put here in a really small volume. I hope my internal microphone can capture this, so I will make a test to show you. Da, which is dash, D, which is a dot, dash, dot, dash, dot. Hope you can listen this. Okay, very interesting. It's not a mechanical, there is no mechanical link here. Usually, in this kind of equipment, you have a mechanical switch, okay? Even in the iambic switches. So this equipment I will show you later on. It's possible to use in two different modes, as a standard keyer like this one. So you can see here in the green LED that it's reproducing the dash and dot, dash and dot. This is a very interesting and useful for keyer a standard input, common application. And it's automatic also. There is a firmware here that controls the speed of the manipulation through the position of this potentiometer, and you can also switch on a controller for a guard time, which I will explain you later on in this video. So it's possible to use the speaker, you are listening, through this switch. I can turn off my speaker. So you're only watching the LED showing which character we are pressing. Are you turning on again? Another interesting trick of this equipment, it's possible to invert the position. If you like to use the dash in this position instead of here, you just invert the switch, and now look at that. Dot, dash, dash, dot, dot, dash, dash, dot. So it's very interesting and useful feature here of this equipment. Also, you can change here the equipment mode. So in this mode now, I can turn off my speaker and I can turn off my LED, and through the output you can see this is working now just right as a iambic switch, as a iambic key. So as soon as I keep my finger in this position here, just make a small touch, because this is a very sensitive integrated circuit. I will explain you later on. Okay, so just make a small touch here and it's working as a iambic, okay, as a iambic switch, a iambic key. So here it's, for example, dash, dot. So as long as I keep my finger pushing, so you keep this on, off, on, off. So this is very interesting if your transceiver have this feature. Normally they have automatic settings for a iambic manipulator. And in this case, you can use this equipment as a iambic too. Look at that. It's very easy to operate. So you have in the same equipment iambic manipulator option and also keyer manipulator option. It's very nice. It's also possible, and I will explain you later on, through time domain graphics. You can use a quad time. It means now, if you wanna press this in a different expected position, in a different expected time position, okay, and this will not working. You make a delay waiting for the proper position to transmit what you want to do. So, for example, this is the dash. So I just decrease the speed so you can see this effect. I try to show you this. So this is the dash. Look, dash. This is okay because I'm still manipulating my character. But if let's see, okay, but if I just untouch here this ball head and touch again, I have to make sure that I touch again in a proper time position, okay? This is very tricky and very interesting. For example, if you know Morse code, you are manipulating a character, okay? So you have normally some rules to make this manipulation, and this equipment implement the automatic the automatic adaptation to this rule. So, for example, you want to transmit one character like letter C, for example. So, da, di, da, di. So it works. So I'm faster than the decided speed here. It's setting. So, and it captures really well. But between the different characters, you have to respect some delay, some time. Otherwise, the other operator would imagine you are still transmitting the same character. You are still working the first character. So this is normally 3 times the smaller time space. For example, the smaller time space in Morse code is the dot space, which is here some milliseconds. This is the dot. Okay? So the guard time is interesting because if you manipulate like that, dot, 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 you are still in the same character. So you are still finishing a transmission of the first character. But if you leave here your finger, okay, over them, I don't know, 1.5 that dot let's say dot time space. It's quite hard for me to make this in English, sorry guys. So if you leave this and press it again, the equipment will understand, no, I'm not supposed to do this right now. Why? Because you just leave the sequence over than 1.5 times dot, and you are supposed to transmit it again 3 times dot later. So this equipment automatically will respect this, and even if you keep your hand here touching this small ball here, he will wait, make a delay, and transmit after this time. Okay, so like that. I don't know if you can reproduce this by this camera, so right. Okay, this is fine. This is fine. Look at that. I keep my hand here, touch my finger touching, and he wait a small delay till blinking my LED. So it creates a guard time. So if you don't want to use this, you have to figure it out yourself when you are transmitting. So between the characters, you must respect at least 3 times the smaller size here, the smaller time here, which belongs to dot. So 3 times dot, it's enough, but you have to do it yourself here. I usually keep it off the guard time, but if you want to turn it on, it's up to you, and you can use this also. So I will increase the speed here for technical purposes here in the transmission, and I will show you some interesting features of this equipment. If you want to transmit, for example, the letter C, okay, which is like that. Da-di, like, let's see. This is letter C. You can transmit like that. So, first one, dash, dot, dash, dot. Look at that, dash, dot, dash, dot. But if you wanted to gain some, let's say, some time, you can just do this, but be careful to leave your fingers when the time is ready for that. Be careful, if you touch before the dot instead of dash, you make something like di-da, dot, dot, dash, look at that. But if you want to transmit the letter C, you have to transmit dash, dot, da, di, da, di. Da, di, da, di. So it's very easy and useful here. This is some software trick to reach the desired manipulation here. So I make this and I explain you later on the software side. Very nice. So as soon you leave your fingers through these ball heads, it stops immediately. Look at that. It's very fast. But if you want to manipulate in the standard way, okay, it also save at least one more touch, like that. I would touch very fast here the dot 2 times. faster than the manipulation speed. So it saves. Like for the da, it works really, really fine. Another trick here, if you want to transmit it, for example, let's see, letter F, which is dot, dot, dash, dot. So like di, di, da, di. Like, let's see. Very, very nice. But if you want to manipulate in the standard way, it works too. If you want to manipulate it here, for example, the letter H, which is 4 dots. Okay, I wanna now number 2. It's very, very easy to work with this switch, as you can see here. Very, very nice application. So it's automatically, if you want to increase the speed here, look at that. Again. Or you can reduce the speed. Look at that. That's it. Let's increase here a little bit. That's fine. It's possible also to change the audio frequency. So I want to put it a little bit lower for the frequency. Lower again. Or I want to put it it's very, very nice to listen, to understand. Okay, and that's all here for the moment. I want to now show you some tricks. I want to show you some diagrams. I want to show you some software side. And at the end, I want to show you a real application with my transceiver and SDR receiver about 10 kilometers far from my house here to show you how it was working in the real application. Okay, thanks a lot.
So I want to show you now some pictures of my equipment inside, and this was the starting, so was the beginning. As you can see here, we have some prototype boards, okay, some called here universal boards for connection and soldering purposes here. So I didn't actually made printed layout, printed circuit board layout for that, but of course you can do it if you want. It's interesting because this side here of the equipment is very, very critical. Here you have the two integrated circuit which is responsible for the touching sensor, which is the AT42 KT1011, okay, AT42 KT1011. So both are the same integrated circuit. One it's for the dash and another one is for the dot, or vice versa. Okay, you can switch between the possibilities here. And this was just the beginning here, okay, the beginning assembling. And in the first moment I was thinking about using 3 different optocoupler outputs for connecting my radio, but at the end I use only 2. So with these 2 optocouplers I can use a stereo female plug, okay, jack, and with this stereo jack I can use an option for a standard keyer, okay, and an option for iambic keyer, okay, iambic manipulator. So in the iambic manipulator I use this optocoupler and that one, and for the standard keyer manipulator, I use only this one. I will show you later on in the electric diagrams, okay. This is the main microcontroller responsible for making all these nice features here. It's a STM32 F103, okay, CHT6, which belongs here in this package here. It's a famous blue pill package here, okay, and it's easier to assemble. I soldering all the inputs here, okay. I make in the down of this board, I make electric connections to provide 3.3 volts, 5 volts, and so on, as I will explain you later on. This is a voltage regulator, which decreases my voltage input, okay, my power supply voltage input to a standard 5 volts. And with the 5 volts, I can feed this microcontroller, this blue pill board, and this blue pill board has also its own 3.3 volts regulator down on the printed circuit board, and I have here a 3.3 volts output, and I can feed my other circuits here, okay. After some days I reached this assembly, but look, it's really really disorganized, as you can see here, the wiring, I mean. So this is very damaging for my operation. Why? Because here it's a touch sensor probe, so this is very sensitive. So through all these long wire connections, I can have many interference between these signals, and I can also have some phantom effects, like you touch the dash and suddenly you have also a D, dot sound. So this was really hard, and it's a very important trick. Try to make smaller connections as possible. So cut as much as you can those cables here, especially in this area of your circuit. So I reserved this area to the touch manipulating, to the touch sensor area, and also the optocouplers, which will send the information to the transceiver. So try to cut these wires too here that connect between the female jack, stereo jack, and the optocouplers, okay. I use only 2, but at the end I solder these 3. Okay, I will leave this here as a spare optocoupler, so if I want to use this in the future, it's there. So this is the small speaker, as I told you before, smaller than even a coin, but it's really strong one. This is a amplificator, okay. This is a amp op for my speaker. This is the small potentiometer I told you before, that you can control the volume of your speaker. And that's it in this area of the board. And here is, of course, the microcontroller and all necessary connections, which I will show you on the circuit diagram. Okay, I tried to make as much as close as possible these mechanical rolls, okay, this drilling. I make all the drills here. Of course, this takes some time to produce. It's a very handmade equipment. You can, of course, make your own in a different way using a PCB here with your own layout, which is very interesting. Okay, I give you some electromagnetic tricks here. At the end, I leave these wires the same size you are seeing here, the top wires, but at the bottom side I try to cut as much as I can those wires. Very important to make a strong grounding connection between this board and that board. So save some holes here to use more than one wire to provide a good, as much as you can, grounding surface on this board. Also, try to use as smaller as possible this cable to provide power supply, okay, 3.3 volts and also 5 volts. I have 5 volts for the amplificator here, and 3.3 volts for the integrated circuits here, for the touching sensors. Okay, so be careful with all this information. So at the end, you can see here, this area here, it's too polluted, so you have many cables. But I try to attach those cables together and put all these cables here in this area and leave this area just for the touching wires, the touching probes. And also here is smaller as possible for the optocouplers, which will transmit the information to the radio. As you can see here, this is a very important hint, and you have to follow this, otherwise you don't have success. Other important information is choosing a proper resistor value for your touching integrators. Okay, so for my case, I use 100 kilo ohms resistors. So as bigger as your value here, you decrease the sensitivity of your probes. Smaller ones will increase the sensibility. Be careful, because this can really have strange behaviors when you have a strong radio frequency return in your antenna system, in your radio system. So be careful with that. So try to do as smaller as possible. Okay, this is important information for the assembling now, and this is the electric diagram. Okay, in the electric diagram here, you can see the touching ICs, okay, integrated circuits, which is the AT42, KT 1011, and you have to, in my case, I use 100 kilo ohms and a 2.2 nanofarad capacitor here, and also there's a coupler capacitors here for the feeding, 3.3 volts. I got those 3.3 volts directly from my blue pill, which is very interesting. And what I can show you more, the LM7805 is the voltage regulator for 5 volts. The LED to show you the blinking of your transmission, of your manipulation. And these PB3, PB4 are the outputs for my radio. Okay, PB3 will be responsible for the D, for the dot. PB4 will be responsible for the dash. Okay, for the dash. So in the iambic manipulation, in the Keyer manipulation, you are only using this part of the plug, and of course the grounding of the plug. Okay, this works very fine with the FT950, and I'm sure it will work with other radios too. Port PA1, it's connecting to my potentiometer to manipulate the speed, for example, or even the frequency response of my manipulation. So this is the amplifier circuit. So the PA08, which is a PWM output, it's connected to my amplifier, and this PWM output will be increased here, and I have here enough power to feed my speaker. So I have PA4, PA5, PA7, and PB9 as the 4 different mode switches I can control. So you can invert the dot and dash function. You can turn on and off your speaker. You can turn on and off your guarding time, which I explained you before how it works. And you can turn on and off the mode switch if you want to use as a Keyer manipulator or as a iambic manipulator. So this is very interesting. So let's go to the software. The software, I will not spend too much time here. I just want to show you. It's all done using FreeRTOS interface. So let's go down here. I split my problem in different tasks. Okay, one task for reading the analog digital converter, which is responsible for reading the signal coming from my potentiometers for speed manipulation and frequency response. I have one task responsible for reading the dot, for reading the dash. Of course, reading input 1, reading input 2. If you invert the functionality, you have to make some tricks here, and you show later on. And one task for processing the dot, and another task for processing the dash, and one very important task which is responsible for reset notify. This task I will show you, it's implemented here, a state machine. In this state machine, I'm doing an implementation to the double manipulation. Remember when I showed you before the procedures when I want to manipulate at the same time dash and dot, and at the same time suddenly I want to leave my finger from the probes, and I want to reset instantly my transmission. So this is responsible for that function. So if you go in here, it's a standard FreeRTOS implementation here. So everything here you probably can see through my online videos regarding the microcontroller, regarding the Hall API for the Cube IDE, okay, for the STM32. So the GPIO, the timers, and also analog digital converter, everything it's initialized here, okay, the clocks for the microcontrollers, and so on and so on and so on. I also leave here some implementation for sending strings through the USART. So in the future, if you want to make a debugger through the USART, you can use it. Okay, it's very interesting if you want to make some debug of your application. I don't know if you want to use the USART for something in this kind of application. Okay, so this is a task for reading the analogic digital converter. So as I told you, I leave here some debug serial information. So if you define this string debug serial, okay, you will immediately turn on this okay, you immediately uncomment, you immediately turn on this information here, okay, this function, and you will transmit it to the serial port, this information. It's just for debug purposes. So here it's a loop for my task analog digital converter reading, and this is very important here. I'm reading analog input from the speed value potentiometer and analog input from the frequency value potentiometer. Both are stored in a 16-bit variable, okay, and of course I putting all this information in a 32-bit variable. Okay, it's only one variable to store all information I need for the speed and for the frequency value. Okay, so this is done here, and I'm using a queue, okay, a queue function from the FreeRTOS to send this information to a queue, and if I want to retrieve this information in another task, I can do it. It's very, very nice to use the FreeRTOS features here. VTask delay and so on. That's it. So from 100 to 100 milliseconds, it's more than enough to make newer reading from my analog inputs. Okay, it's not necessary to run too fast, but those other here are very important to run as fast as possible. I put all those tasks in the same task priority level, which is the idle priority level, so they should work in the same priority. So here the task reset notification, as I told you before, is a state machine implementation with different states. So in the first state, I check if I press it at the same time probe 1 and probe 2. I'm not telling here that and dash. I'm telling probe 1 and 2. So I put 5 milliseconds, which is here for bouncing proposals, and I go to the second state. In the second state, I check it again if it's pressed. So if both are pressed, it means I'm manipulating through that kind of manipulation I told you before. If I want to transmit a letter C as fast as possible, I only need to press at the same time, let's say together, not at the same time, but first I have to press the dot dash and second the dot, but really fast, and keep those probes pushing. Okay, so here the third state of my machine, now you check if I leave one or another one. If I leave probe 1 or probe 2, I go to the last stage, and in the last stage I will check if I leave both at the same time. So if I leave both at the same time now, it means please notify those tasks, procedure dash and procedure dot, that I want to stop it, that I want to not transmit again till I press my probes again. Okay, so this is how it works. So the task read dot, so it's responsible for reading the button 1, for reading the probe 1. So this is also a bouncing here function. So it looks if I press the probe 1, if I still pressing the probe 1 after 5 milliseconds. So if this is doing like that, I will check it. If I'm working in the inverting mode or non-inverting mode. If I'm working the inverting mode, I want to notify the dot task. If I'm working not in the inverting mode, I wanna send information to dash task. So I don't want to go to dig deeper these functions here. It was not so easy to implement, but it was, I'm sure, much more easy if I want to go to the bare metal implementation. This was very nice in my opinion to use free RTOs. Okay, so there are some tricks here if you want to leave some button and so on. I don't want to do that too much. Read dash is mostly the same, so the only difference is because now I'm looking for another button, okay, and I'm sending information to another task, for example. And here this procedure dot and procedure dash tasks. So the dot one, it waits for information here, okay, it's waiting for a task notify. If the task notify comes to this function, it just go down here to this bracket and you check it. It's bit set, okay, the status value is bit set. Let's suspend the task for the dash. Look at that. I'm using a free RTOS function to suspend the dash. So in this moment, I will procedure the dash dot. I don't want to put this task running for the dash at this time, because I'm at this time processing only the dot function. This is very tricky and very important. So I'm doing a lot of things, receiving the cue for with the analog values, checking the analog values, putting all this information, okay, of the analog values in the speed value variable, frequency value variable, make some calculations for speed, which is a formula, okay. I don't want also to spend so much time here, blah blah blah. And here is also the guarding time. So if you are using the guarding time function, this area now will produce a delay in your application. Remember when I explained you about guard time? So the guard time, you will wait 3 times the smaller time value, which belongs to the dot, so which is the speed value. So I have to put 3 times this, make some calculations to make a precise delay to guarantee that I'm now between the transmission of one character to another one. And at the end now, next I will set the keyer pin, okay, and the LID pin too, just to make the manipulation and send to my radio. Again, if my speaker is off, so if my speaker is off, I will not, if my speak is on, I will make a PWM start. You manipulate the PWM to generate a proper frequency to my speaker. And I will put a delay here. This is a speed val delay. So this is a dot delay, which is the smaller delay you can have. Remember, I'm now in the dot processing task. So I create a delay for the dot, which is the smaller delay, as I told you. If you know, if you don't know, just try to make some research about CW, about this very interesting science, I would say, the Morse. Okay. After this time, I will release, I will turn off, I will reset my keyer output and also my LED output. Okay, I will also turn off my speaker if I'm choosing to work with my speaker, and I will put again a dot delay, because you have to be sure you transmit the dot with a specific size, timestamp, and you have to make sure that you have a delay after that about the same timestamp. Okay, after that I can resume the task for processing the dash. So if during this processing I'm pressing also the dash button, this will store the information here, because the read dash and read dash dot tasks are running really fast, 1 millisecond task scheduling. Okay, so if I press during this time the read dash function, this will send the information to my will notify the processing dash task. As soon as the processing dash task is released in the kernel here, you will run the processing dash task, which is more or less the same of the processing dot. The biggest difference here is I'm using, for example, I'm using 3 times the speed val. I'm using the 3 times the smaller timestamp, which belongs to the dot. So dash, it's 3 times dot. So it's a very important concept. So this is all we have for the software side. I hope you like it. Okay, I'll decrease a little bit the volume now. So now I will show you how this works in the real life. So this is my FT950. I set the equipment here to work as a standard keyer manipulator. Okay, it's working as a standard one, and I'm not put here the button to make an automatic keyer calculation. Okay, automatic keyer manipulation inside the radio. So all these procedures to adapt and to make the proper transmission will be done in the electronic of our automatic transmitter equipment here. Okay, device. So it's upper sideband CW function 28.100 megahertz. Okay, so everything is set properly for a transmission. And here in the State University SDR, 10 kilometers about from my shack here, I will put here at the central frequency of 2800 CW function, as you can see here, for 100 Hertz here the bandwidth, and I will turn up the volume. Okay, as you can see here, now I start to transmit my call sign here just to make a test. Okay, let's see. So as you can see, it's working tremendously. It's really, really, really nice, this equipment. So I hope you enjoy this. Let's try to do here the letter C and the letter key CQ with the other kind of transmission I told you before. Okay, this is really, really fine. So I hope you like this video. I hope you enjoy, and I hope you want to do this to build your own CW, your own manipulator. Okay, thank you very much for watching Electrocursos, and see you in the next video.